Alright, so there was a question about graphing systems of equations. So let's go over that. Graphing systems of equations. Alright, hopefully this one's going to show up a little better. Okay, so here's an example. X minus y equals 7, and 3x plus y equals 1. So there's our two equations. So we are going to graph each of these equations separately, just like we did in the prior unit. And then our goal for this unit is to find the point where those two lines cross. So I'm just going to look at one equation at a time. So this first one, x minus y equals 7. I could graph this in two ways. One way, I can make a table and I could substitute 0 in for x. So 0 minus y equals 7. So negative y equals 7, right? Because 0 minus y is just negative y. And then I'm going to divide by negative 1, because a negative divided by a negative is a positive. So this becomes positive y, and this becomes negative 7. So when x is 0, y is negative 7. Then I'm going to find where y is 0. So x minus 0 equals 7. Well, x minus 0 is just x. So x equals 7. So now I have 7, 0 as my other point. So then I can graph this by drawing my grid. And you guys already have graphs on your packets, but I do not. So here's my x and y. So here's 1, 2, 3, 4, 5, 6, 7. So I have a point. The second point here is at 7, 0. So over 7 for the x and up 0 for the y. And I also have a point at 0, 1, 2, 3, 4, 5, 6, 7. This is negative 7, this is positive 7. So I have this other point right here at 0, negative 7. So there's my other point. And then I can connect those dots. And here's my line. All right, and then I have my other equation, which is at 3x plus y equals 1. So I'm going to do the same process with this one. Use red for this line so we can tell the two different lines apart. So I'm going to substitute 0 for x. So 3 times 0 plus y equals 1. So 3 times 0 is just 0, so y equals 1. And then 3x plus, again, I'm going to put 0 in for y, equals 1. So then 3x equals 1, so x equals 1/3. Okay. I am not loving the idea of graphing 1/3 on this particular grid. I think it's going to be really hard to be accurate, and when you're graphing systems, you have to be very accurate. So I'm going to pick another value for x just to give me a second point that's going to be easier to graph. So I'm going to say, well, what if x is 1? So then I have 3 times 1 plus y equals 1. So 3 plus y equals 1. Subtract 3. So y is -2. Okay, so now I have these two very graphable points at 0, 1, and at 1, -2. And then I'm going to very carefully, actually I'm going to find one more point because, oh, I'm good. I'm just going to go ahead and draw the line. Okay, so then it looks like, am I on the screen still? Okay, it looks like our lines are crossing at 2, -1, 2, 3, wait, 1, 2, 3, 4, 5, -5. And then to double check that, we can substitute that point into both equations to make sure that it works. So I'm going to go 3 times 2 plus -5 equals 1. 3 times 2 is 6 plus -5 equals 1. Yes, that works. And then with the other equation, x minus y equals 7, I have 2 minus -5. So we got to remember the minus from the equation and the negative from the number equals 7. Minus the negative is plus, so 2 plus 5 equals 7. Yes, that works. That's true. Okay, so there's one way, one method for graphing a system. I'm going to show you how to do this exact same problem using y equals mx plus b. So then you have two different methods that you can pull from depending on your preference. So, same system, x minus y equals, forgot already, equals 7, and 3x plus y equals 1. Okay, so to use y equals mx plus b to graph the two lines, I'm going to get y alone in each equation. So again, I'm going to rewrite this over here, give myself some room. So I have, I want to get y alone. I want it to be y equals mx plus b, with m and b are both going to be numbers. So I'm going to subtract x from both sides because my goal is to get y isolated. And then I'm going to have -y equals -x plus 7. These are not like terms, so we can't combine them, so we have to just leave it -x and +7. And then I'm going to divide everything by -1 because in our formula y is positive. So divide everything by -1. So y equals -x divided by -1 is +x, and +7 divided by -x, -1 is -7. So there's my first equation. In this equation, I don't have an m value, but if we think about what times x would just be x, it's 1. 1 times x is just x. So our m is 1. And my b value is -7. So on my graph, on my graph, I'm going to start at -7. This is where I start. 1, 2, 3, 4, 5, 6, 7. And then that's my first point for my line. So I'm going to make a point there. And then my slope is 1. Well, we want it as a ratio of rise over run. So I'm going to go up 1, and I'm going to go over 1 with this slope, because 1 divided by 1 is 1. So up 1, over 1, up 1, over 1, up 1, over 1. And again, I want to be really precise with my graphing to make sure that I find the right point where my two lines are going to cross. I find that this method gives you a much more exact line than the other one when you're graphing, because you can just use that slope to keep going. So there's one line, and then again I'll use red for the other one. So 3x plus y equals 1. If I want y equals mx plus b, I want my y alone, so I'm going to subtract 3x from both sides of the equation, and I get y equals -3x plus 1. It's a positive 1, so plus 1. So again, my m is this number right here. It's -3, and my b value is positive 1. And since again my m isn't a fraction, I'm going to rewrite that as a fraction. So this is going to be down 3 for every 1 I go to the right. Okay, so I will start at 1, positive 1, and then I'm going to go down 3, 1, 2, 3, and over 1. And then down 3, 1, 2, 3, and over 1. And we are intersecting at that exact same point. As the last time, which is right here at 2, -5. All right, thank you.